All right, let's go ahead and begin. Bella, if you want to open those windows, that's totally fine if you want to do that.
Go ahead. Open that one if you want. Open the
Forget about those people. You got to be assertive, Bella. I'm just kidding. That was.
No, open that one. Open that one. Behind you. Oh, yeah, do that.
There you go. Just crack the window. No big deal. Sometimes we all get a little overheated, especially me. What? It's true. I'm a member of Overheaters Anonymous.
I love me. I'm like Fire Elsa. The heat never bothered me anymore.
I sleep like at 130 degrees.
Hey, can we do math?
Yeah.
No, why are you so?
All right. We should start math because this is a very quick lecture and you guys can get out of here quick, right? And so the best thing to do after this lecture, I will be available in the Student Center. You should go and review everything you studied until now. I can tell you're going to do it. That look on your face.
I want to take my kids up to 5.
She just gave me a look like, yeah, right. Tessa, you got a question?
Just seeing that that first problem when it says the square root of 100 over divided by the square root of 4 equals 10 over 2.
Uh-huh.
It would be 5.
Yes, that is correct. This is equal to 5. All right, so let's go over dividing rational expressions. So remember, previous classes we went over what roots and radicals were. In the last class we saw how to simplify something under a radical. Let's just go over that real quick so you guys remember. Deja, you okay? Okay. All right, guys, so if I want to simplify the square root of 50, remember how I do this. I split it up into a number that is a perfect square and whatever else, right? So 50 splits up into 25 and 2. 25 works because it's a perfect square. So the 25 turns into 5 and the root 2.
Or root 2.
Yeah. All right, and so that's what we did in the last sections. In this section, we're going to learn more about how to divide these things. So the rule for division basically says, if you've got a radical on the top and bottom, you can extend that radical over the entire fraction. The reverse is also true. If you start out with a fraction with the radical over the whole thing, you can split that up into 2 different radicals. Something you need to watch for when you do this, if you have a situation where if you have 3 roots 4 with like a root 2 on the bottom, this is not one of those problems that you can put the radical over the whole thing. Yeah, because the 3 is not under the radical. You'd have to write it like this. You'd have to say 3 times square root of 4 over 2. Yeah. Right? So that's just a quick little caveat there. All right. So let's go ahead and learn how to divide and simplify these guys. So right off the bat, we have 27 over 3. We notice that those can be simplified if we extend our square root. Yeah, so this equals 27 over 3, which ends up being root 9, which we know is equal to 3. Good. Okay, we're going to do the same thing with this guy. Right? We're going to extend the square root over the entire fraction and then cancel as appropriate. All right, and so on our next step, the 8 over 2, that turns into 4. 8 to the 7 cancels 1, and we get a to the 6th. Now we're going to break it up one more time.
2a3.
Right, I have root 4, and then I have a cubed squared. So the 4 turns into a 2, right? And then if you take the square root of something and then square it,
It's 8.
that thing just pops out, a cubed. Okay. Once again, just remember this was a square root. We started out with a to the 6th, a cubed. We just halved the exponent basically. Okay. Sometimes it helps to simplify by basically splitting up the square root instead of combining it, and so this is a good example. We can see we have two perfect square. We have a perfect square on the top and the bottom, so we can split this up into root 36 over root 25, which gives us 6/5. Yeah. All right. Root 1 over 16. Split this up into root 1 over root 16. Yeah, exactly. And then we get 1 over 4. Nope. 49 over t squared.
7.
Yeah, exactly. Root 49
Turns into
over root t squared. Right, 7 times 7 is 49, so that's what pops out. T times t is t squared, so t pops out. Any questions on this stuff?
I have a book.
You guys good? All right.
I got it.
All right, and so suppose we're asked to simplify these. So let's see now. Do I want to simplify this guy first?
Don't do it the way you've been doing it.
7
All right.
over 25?
Yeah, so let me just split this guy up maybe.
Yeah.
Although 7 over 25 is tempting.
That's both of them half.
I want to do that first.
Okay.
Yeah.
I think it'd be silly not.
And the reason why is because the number 14 doesn't have any perfect squares contained in it, right? And so if I split these two square roots up, I'm going to have root 14 at the top, and that doesn't simplify into anything. And so it can't cancel with anything on the bottom, right? And so that's not really a good route. So I'm going to do the simplification first. So just like Deja said, this is going to turn into 7 over 25. Okay. Doesn't really help me that much either.
It's the same thing.
And so then we end up with, no, that is better, yeah. And so then we end up with root 7 on top, root 25 on the bottom, then we have root 7 over 5. Yeah, and so yes, that is a little bit better. Not a ton better, but it's a little bit. Yeah, so you know, if you start tackling these and it ends up to where you can't simplify, try something different. You should be able to simplify these at least a little bit. All right, and so
X cubed. 3x. 7.
let's just go ahead and simplify things before we mess around on this one. Why not? Is 48 divisible by 3?
Yeah.
What do we get? I have a calculator now. 16? Aha! All right, so we have 16 on top. I'm going to collect my x's on the bottom because that's going to avoid negative exponents. So 2 from the top cancel. All right, sorry, 3 from the top cancel, and that's going to give me a 4 exponent down here. So x to the 4th. Everybody see what I just did with the x's?
Yeah, but what about the 3x? Where does the 3 go?
Whoops, that wasn't supposed to be highlighted. That was supposed to be erased. Yeah, so the 3
Oh, I got it. Yeah.
flips down and we subtract it from 7. Yeah.
That was a hot mess there.
Right, and so now we can see this is what they wanted us to do because here's
because
2
they can
perfect
simplify
squares.
more.
Yeah, so now we split it up. We have root 16 in the numerator, root x to the 4th in the denominator. 4 pops out in the numerator, and x squared pops out in the denominator.
So 4x. That's the answer, right?
4 over x squared, that is the answer. All right.
Short lesson.
Not done yet. We have so much more. Just kidding. It's like,
I know,
it's
yeah.
super quick. That's it. I know.
20-minute lecture?
Yeah. Take advantage of this extra time and study what you've been through so far, right? Because we're coming up on not only exam 4, but the final comes right after that. And so starting to study now, see, we're already stressing Bella out.
I have to take it earlier though.
Oh, do you? Oh, that's right, yeah. Make sure you work that out with me. Oh, so does Jarrett.
I have 17.
Yeah.
Oh,
And he already forgot.
Wait a minute. When are you guys taking the exam?
2 days after the 4th test.
Wait, why? Are you leaving?
Yeah.
yeah, I'm leaving. It's 17 days.
Yeah. So if you guys have something scheduled during exam week, like, you know, I can let you take it early if you want.
Okay.
No.
I don't know.
Oh, yeah, it's before the night. The finals is before the night.
Okay.
It's like the 4th or something.
I'm gonna fly out of the night, so I'll fly.
Gotcha. All right. So.
Anyway.
Oh, yeah, that's right. So rationalizing the denominator. Okay, so we just went over how to simplify stuff, how to extend the square root. Now we're going to go over what's called rationalizing the denominator. So for any problem to be called simplified, we don't want a radical in the denominator. This problem is not simplified. We have to get that out. So to do that, all I need to do is multiply top and bottom by by the same radical, basically.
So, root 2.
Root 2 over root 2. Right? Once I do that, root 2 times root 2 equals 2, and then root 2 times 1 equals root 2. So this is the correct version of this expression. All right, so if we're asked to rationalize another denominator, right, we have root 2 in the denominator again. So I just multiply root 2, and that gives me 3 roots 2 over 2.
You just follow it across.
And we're done. Yeah, exactly. All right. Oh, okay. So root 5 over root A. All right, I'm just going to split these guys up. We have root 5 over root A. I'm going to multiply top and bottom by what?
A.
Hey.
Root A.
Oh yeah, root, sorry.
That's what you meant, though. I already know.
It
you
was, I didn't.
All right, and so then we have the square root of 5A,
5A.
right? And that is over plain old A,
Straight A.
right? Okay, so now we have root 45 underneath root 2. Why don't you guys try this one on your own? Let's go ahead and give it a shot, just so we can jar your...
2 over...
Yeah, try this one here. Root 2 over root 45. Go ahead and rationalize that denominator. Yeah, multiply top and bottom by whatever the radical is in the denominator. What's up, Tessa? So this is what we do, right? So we decide we do not want a radical in this denominator anymore. So we multiply the top and bottom of this fraction by the radical part of the denominator.
Root 45.
Right, yeah, in this case, the whole denominator is the radical part. So we multiply top and bottom by root 45. Oops, 45. That gives us 2 times root 45, 2 roots 45, which is 90. Right?
90
Yes.
Over, 90 over 45.
90 over 45. Now we want to simplify 90 a little bit though, right? Yeah, because we can pull a 9 out of 90 and 9's a perfect square. So I'm going to go ahead and do that. So I'm going to write this as square root of 9 times square root of 10. And that's still over 45. So now the square root of 9 turns into 3. The 10 just stays as roots 10. We have 3 over 45. Exactly. 3 over 45 turns into 1 over 15. So I get root 10 over 15. And there we go. Okay, last one. So this one, once again, we split it up. And just because there's variables there, that doesn't mean we treat it any different.
Over 12A.
12A, multiply top and bottom by root 12A. That gives me 12A on the bottom. And then what? I don't know. What the heck 7 times 12?
14, 7, 84.
84.
84, okay.
No, I'm proud of you for actually getting it right this time.
I know. Are you channeling Gabe today? What's the deal? That was a nice multiplication there.
Math all day.
Right?
But I hate me calculator. I can do more complex problems.
Oops. The X will help.
Oh.
The X will help.
All right, so now I'm going to keep on canceling. Right? And so 84 splits up into 4 times 21. And then the a cubed, that also is going to split up. So I'm going to split up the 84 first. We have 4 times root 21. And then the a cubed, that splits up into a squared and a plain old a.
Yeah.
Right, and so I'm going to write my results down here. So I'm going to bring everything I can simplify out front. So I have root 4, that turns into 2. A squared, that turns into plain old a. Right, and then the 21 and the a stay there. Root 21a. That still goes over 12a, which means we can cancel some stuff. Boom and boom and boom and boom. And we get 21a over 6.
Yep.
Okay, let's do one more quick just to show you some weird stuff, every once in a while you might run into something like this. 3 roots 2. That was my magic.
Magic.
Yeah. Ooh.
Are you recording?
Yeah. Luckily, my boss doesn't review these. All right. So no, I'm just kidding. They wouldn't care. They're cool. They're cool with it. So remember, all I need to do is I need to multiply top and bottom by what's in the radical. The 3 is not, so I can ignore the 3.
The
Yeah.
3 has nothing to do with what we're doing.
Exactly. Yeah. You just.
When you divide them, it has nothing to do, right?
So since I'm only asking you to rationalize the denominator, the 3 has nothing to do with it. Yeah. Now, if we were trying to get rid of all our denominators, we were trying to cancel, then we'd include the 3. Yeah. But since all I'm asking you to do is rationalize, it doesn't really matter. So root 2, and then I have root 2 over 3 times 2, root 2 over 6. And that's it. You guys have a very wonderful day.
Did you rock?
I'm sorry for that slog of a 15-minute lecture.